let's get started. We have another awesome lineup of tracks this afternoon. I'm going to kick things off talking to you a little bit about Lassie. And then later on, we have talks from the right immediately following that. We'll hear from Reed from the Saturn team. And then we have talks about the motion, the D-Store Filecoin REST API, aka sometimes called by the code word motion. It's a new product for enterprise storage and retrieval. And we have a talk from the Titan network coming up, a talk from the state channels team, which I know a lot of folks are really excited for because we've been mentioning their work a lot. And we have one more. No, do we have one more? I think we do. I'm trying to remember which one it is. Anyway, it's all coming up, so let's get started. All right, I'm going to talk to you all about Lassie. A lot of y'all have already maybe heard of Lassie, you know a little bit about what it is, but I'm going to try to do a very brief intro for those of you who don't know what it is. It is simply a program you can use to retrieve your data. It is a retrieval client, and our goal. It's essentially designed to be a simple command line tool or library that you can use to retrieve data from IPFS and Filecoin. It is targeted towards universal retrieval. Our goal is always to make retrieval simple, so that you don't think about what protocol you're using to transfer data. You don't think about how you're going to find the data or who's got the data. You shouldn't have to worry about these things. It is intended to be an abstraction. You should be able to tell Lassie to fetch, and your SID, and it should just work. So that's the kind of North Star of our development. We introduced Lassie at IPFS thing in April. This talk is going to be a bit of an update. So if you don't know anything about Lassie, I apologize. This isn't going to be really an introductory talk. I would encourage you, I even put QR codes if you want to go read about, go watch some other YouTube videos that are more like introduction to what is Lassie and how does it work. But I want to talk to you about what we've been up to. So, what's new with Lassie since I gave talks in April? First of all, Lassie has gone full HTTP. When I introduced Lassie in April, it's always included an HTTP server component, so you can talk to Lassie through HTTP. But initially, Lassie was only able to retrieve content from backend providers over Bitswap or Grasshopper. It is now fully integrated with HTTP trustless retrieval, which I'm going to be talking a little bit about in a bit. We do a lot of our retrievals over HTTP, including specifically to Daghouse is probably our single biggest HTTP provider, but we are increasingly starting to serve retrievals from storage providers over HTTP. So that's exciting. And I will talk a little bit more about that in a bit. The other thing, this slide really did not come out great in the PowerPoint translation, but you can just imagine a party of dogs. That's what that actually is originally an image of, obviously. So Lassie's been going everywhere. This has been kind of cool. It's been some places that Lassie's getting used. It's in Saturn. That was the original use, or one of the original uses. Originally it was in auto retrieve, and now it's in Station and Spark. So that's pretty cool. That's how Spark ultimately executes the retrievals for checking. It's moved into this new product called the D-Store REST API, aka Motion. Lassie is being used by from some of you who are storage providers to to see if your retrieval is configured correctly and find out if it's working. one of the coolest uses of Lassie that I've heard of is that it is now being used by this project called Old Faithful by the Triton group to basically, they're now storing the entire Solana chain. They're putting it onto Filecoin, and then they're using Lassie to serve it. And apparently, they're just able to use it. I have not ever really gone in depth with them, but they seem to be able to make it work, and that's really cool. As someone who has been in this ecosystem a while and built a few things that didn't really take off, GraphSync, it's really cool to see, to build something that kind of has a little bit of a fit for people. And the thing about this is, I think, anyway, people like using Lassie because it works, right? I actually have heard this a couple of times. I'm not saying it's perfect, and trust me, I know some of you guys have had some issues, but like at a baseline, it's a thing that works and just gets you your stuff. And I want to just briefly mention two things that are making that happen. First of all, there's a technology in our ecosystem that was like 3 versions of this slide. I guess the image like got caught up over 3 different, anyway. Like, if you go to a talk about a year ago, if you went to the IPFS thing 2022, all anyone was doing was complaining about how IPLD sucks and it's too complicated. Well, part of the reason Lassie just works is because IPLD. We have been building out these IPLD libraries, including, and even including selectors, which is like everyone's least favorite IPLD feature. But that's what makes Lassie work. Lassie has the ability to execute queries in really predictable ways, and that's what makes it possible to get the data. And we've actually been taking a lot of these libraries and extracting them from Lassie into general purpose libraries. So for example, if you're working in Go and you are talking to a provider that serves trustless HTTP, we now have a little mini library you can use where you can just ingest that response and verify it with just this library without having to incorporate all of Lassie as a library. So that's one key feature. I actually just want to point that out because IPLD is a really complicated tooling structure for a lot of people, a lot of complaints. But it's also when you've really built out the tooling ecosystem, and that's really only true in the Go language, you can do a lot of really cool stuff with it, and it's pretty cool. And I want to tell you about one other thing that's making Lassie work. It's just, dude, I just want to give a shout out to Ron. Ron is like the secret weapon of Lassie's development team. He's written a lot of the core features, and like he's also the IPLD steward in his free time, and doesn't get a lot of love for that. And he's one of the keys to our success in building this tool. So I just want to give him a shout out. Yeah, that's cool. I want to talk a little bit about looking ahead for where are things going with Lassie, right? Few things that I'm seeing, just in terms of when I think about the development of Lassie. Lassie is going to be a tool, and it's going to be used in a lot of places. I'm not like I'm working on Saturn. Other people are working on other products, and it's going to be a tool that's developed in a shared manner. So I just want to talk about some things that I see as critical for the future. So we have this HTTP trustless retrieval protocol. It started with just we've had the IPFS gateway for like, I don't know, 10-ish, not 10 years. Could be like 5 years maybe, I'm not sure. And you could always get a car file from the IPFS gateway, and but there were a number of limitations. And we started with just this like improvement proposal that was just like, how can we add the minimum amount of things needed to essentially serve the existing IPFS protocol, which serve like gateway protocol. If you go to the gateway, you can ask for files and directories in certain ways via this trusted gateway, and it renders them into flat files. And what we wanted to do first was just get the trustless version of that protocol to parity, so that you could serve directories, that you could serve byte ranges and files, you could serve files that are deeply nested paths within a directory, all in a trustless manner. And it was just this sort of like one IPIP that sort of creates like a half new protocol. And it's been implemented, and now it's been implemented. We've actually kind of built on it. We added a few things that came up during the development that we were like, we're definitely going to need this. And there's like, now there's more coming. And this protocol has actually kind of become like a fully fledged data transfer protocol over HTTP. And I think it's actually pretty critical to like where we're going. It's not a complex concept. You serve car files over, HTTP semantics with some basic querying that's very similar to how you would query a file folder structure. You need to be able to list directories, you need to be able to go in through paths, you need to be able to pull out ranges of files. That's all it really is, but it actually covers like so much of the querying we need to do, and it produces a protocol that you can retrieve over HTTP, and we've implemented it in a bunch of places. It's in Daghouse, which is a completely JS-based implementation. It's on storage providers, it's in Lassie, it's in, Saturn. There's just a lot of places that it's going, and I think this is a neat, thing to keep building on. Some thoughts that I would like to see from this protocol. We have these abstract querying semantics, but currently they really only work for UnixFS, which is sort of like the OG of, Filecoin, of IPFS DAG-based file system structures. And there's probably some better ones we could be building for, like WinFS. Maybe we could introduce some big block support so that we don't have to keep breaking up large files into giant unnecessary block trees. Anything that's like kind of like that file system tree structure, we could be building into this protocol. And I think we should. I think it would be awesome. The other thing that is probably coming is this whole concept of an attestation. This is where the Spark project comes in. So we're thinking about how do we produce some metadata at the end that allows a client and a provider to to essentially attest that they both successfully retrieved a specific SID. So that's probably something that's going to come. Another part that we don't have currently in this protocol that would be really nice to add is some support for payments for people who want to do direct in-band payments. Whether that ultimately is a chain-based transaction or not, it would be nice to have that kind of support at some point. So there's a lot of places that we could keep going with this trustless protocol, and I think there's a lot of potential there. Another thing that we haven't quite fully gotten to in Lassie is really building out the performance optimization around how we retrieve among multiple peers at once across multiple protocols. Right now, our strategy is really simple. We race protocols. Basically, if I talk to IPNI, and it says your content is at these 4 different people, and they're serving over these 2 are on BitSwap, and this one's on HTTP, and this one's on GraphSync. We simply start a GraphSync retrieval, an HTTP retrieval, and the BitSwap retrieval, which splits among the peers. And they're all just happen at the same time, and whoever finishes first, great. Well, that's not a super efficient strategy. It also, like within protocols, like if you're not doing any attempt to break the requests up for the most part, other than through BitSwap, which is already broken up by the block. And this was actually one of our original core endeavors that we wanted to do with Lassie, was really get smart about retrieving across content address networks. We haven't done it yet, and largely we haven't done it because we haven't needed to yet. Surprisingly, a simple approach, even if as long as it can talk to anyone, even if it's not the most efficient in a lot of scenarios, it doesn't really matter for like a cache miss type scenario, for example, in the Saturn network. Because again, those layers are often not expecting that kind of CDN level performance, the layers that Lassie primarily talks to. But yeah, that's another thing to consider. Another thing that it would be really, just want to take a brief digression and mention one thing about Lassie. Lassie is a really awesome abstraction to over all of the complexity of retrieving on content address networks. And if you dig into the code, it is not always simple or easy to read. And I actually want to point this out, that some of the most, just because this was brought up this morning, I was thinking about it, why can't we make all this simple? So many of the most simple things that we use that we think are awesome because they're so simple are simple because they hide so much complexity. Like your iPhone that just works, it's not a simple device, right? So I just want to identify that. And part of in my opinion, one of the tricks is defining the boundaries of what your abstraction does. And if you can define a good abstraction, and we've kind of gone back and forth on this in Lassie, one of the big boundaries we set is we weren't going to have a block store. We were not going to permanently throw data into a shared block store and read from local disk. And that abstraction is a useful separation for us. There actually are ways where it can work within a block store context, but it's not our goal. Another one that we kind of gone back and forth about is like really large retrievals that need to be broken up over multiple requests. We have not implemented that, and I wonder whether that should be implemented at a different layer. I'm not sure, but I think that might be an interesting thing. Yeah, so this is just a topic of discussion. One other thing that I hope, the last thing I'd like to see us do a little more of is taking some of the cool tooling that we've built in Go and putting it in other places, in particular into JavaScript. So if we can build some of the verifiability tools and some of the IPLD tools into JavaScript libraries, this part can always run in a browser. It's not a complicated part. The part you can't run in a browser is the part that like finds lots of different providers and then there's data transfer over multiple protocols. But verifying untrusted data, content address data, is something that you can put into libraries that can run in the browser as long as they have an endpoint they can fetch from. And I would like us to really get that nailed down because I think it's a critical part of our ecosystem. And lastly, the sort of Lassie secret superpower that I think is part of how it's getting into lots of places is that it can be used as just a code library. And this is how we were able to integrate it pretty quickly into the dstore Filecoin REST API to do some very large retrievals over Filecoin, is that we could just use it as a fetching library. And that was pretty cool. And we're gonna keep working on that to really get the API surface really honed in. It's another thing that might happen is the HTTP server that's currently part of the project, and has been since the start, might move out of the project. Because really that was built as a language bridge for Saturn, and Saturn might be ready to use Go as its core L1 node server platform. So yeah, I don't know if that makes sense long-term. At least living in the Lassie repo would probably still be an open source thing that you could use most of, but it's something that I would like to see move out of the project to keep the project, not too complex. That's it. Let's talk.